All right, let's get going with 9.3. And so now we're going to introduce geometric sequences and series, building off of the arithmetic ones that we did in 9.2. All right, so with arithmetic sequences, we had a common term, which we labeled D. And so we were always adding by the same amount. In geometric sequences, we're always multiplying by the same amount. So if the ratio of one term over the other is the same as the third term over the second and the fourth over third, if we are always multiplying by the same amount to get from one term to the other, we've got a geometric sequence. So we can see a couple examples here. Example 1a is geometric because 4 divided by 2 is 2, 8 divided by 4 is 2, 16 divided by 8 is 2, which means that our ratio, our r, our multiplying number, is 2. And so this equation would be 2 to the n. Same thing here if we did 4 times 3 to the n. Our multiplying number here is 3. 12 times 3 is 36. 36 times 3 is 108, and so on and so forth. All right, and then we also have a divide by 3, which is the same as multiplying by a third, and with a negative in front. This is, remember, we have that negative 1 to the n. This is still negative 1 times a third to the n, so we're going to alternate signs, negative, positive, all the way through. So, exercise 5, see if you can figure out whether this is a geometric sequence, and if it is, find the common ratio r. Alright, so building off of that, we can come up with an equation for the nth term of our geometric sequence, just like we had one for the nth term of our arithmetic sequence. This time it's going to be your initial number times your ratio to the n minus 1. Okay, so how many times are we going to have to multiply after starting at the initial term? So, the example here, write the first 5 terms of the geometric sequence. If we start at 3, so a1 is 3, r is 2. That means every single time we're going to multiply by 2. So a2, 3 times 2 is 6. a3, 6 times 2 is 12. a4, 12 times 2 is 24. And a5, last one, still timesing by 2, 48. Your turn, exercise 17. All right, so let's find the 15th term of the geometric sequence, whose first term is 20, a1 is 20, so we're going to use the formula this time. R is 105. So a sub n, a sub 15, equals a sub 1, 20, times r, 1.05, to the n minus 1, to the 15 minus 1, or to the 14th. All right? Calculator for this one. And so we're going to go 20 times 1.05 to the 14th. Correct answer is 39.5, nope, 0.6 if we're rounding up. All right, so same thing here for exercise 35. See if you can figure out the 10th term. All right, so find the 12th, same exact thing here. Find the 12th term of this geometric sequence. We know from looking at it that a1 is 5, and then our ratio is 15 divided by 5, or we could go 45 divided by 15. Two adjacent terms dividing each other, and we get 3. So now let's just plug it in. a12 is a1 times r to the n minus 1, or to the 11th. 5 times 3 to the 11th. Calculator on this one again. 5 times 3 to the 11th. What do we have here? 885,735,000. So you'll notice here things get really big really fast because we're multiplying every single time. Your term, find the 9th term of the sequence that goes 11, 33, 99, and so on. All right, so now we get a little more complicated here. The 4th term is 125. The 10th term is 125 over 64, but they don't tell you the first term, and they don't tell you r, and we need to find the 14th term. So Let's find r first. Here's what we're going to do. We're going to say, okay, the fourth term is 125 times r. We're going to multiply 125 6 times. And the reason why we're going to go 6 times is because to go from A4 to A10, we would need to multiply 6 times. Once to get to A5, twice to get to A6, right? And so forth and so on. And that's going to equal 125 over 64. And our job here is to solve for r. So let's divide both sides by 125. So we can cancel these out. And 125 over 64 over 125. Let's multiply by the reciprocal. Hey, look at that. Those cancel out. So 1/64 is equal to r to the 6th. And I believe that's a half. 2, 4, 8, 16, 32, 6. Yep. And if you weren't sure on that one, what we could do is on the calculator, we've got 1/64 to the 1/6. We want to take the 6th root of this to cancel out to the 6th. To the 1/6 power and 0.5. 1 over 2 is our r. All right, so now we have r. And we want to find the 14th term here. So we're going to say A14 equals A1 times r to the 13th, right? And we know r is 1/2. Let me plug that in here. So on this one, we could go all the way back there, or what we could do is say we were going to go A10, or let's use A4 because it's a nice one, times r to the, how many jumps is it from the 4th term to the 14th term? Going to multiply times 10 to get the 14th term. So A14 is, the 4th term was 125 times 1/2 to the 10th. Because we're just looking for how many jumps we would have to make to get all the way up there. 1/2 to the 10th times 125. And we've got that, 0.122. All right, so see if you can work through that, all those steps there for exercise 53. They're going to give you the 4th term and the 7th term. You find the 6th term. All right, so now what do we do if we add them all up? And we go from the sequence to the sum of a sequence. So if we have a finite sequence where it ends, right, we don't go on forever, we have a nice formula here. It's the first term times 1 minus r to the n over 1 minus r. And if you have a summation formula, it's a1 times r, right? So r is the multiplier in here. We're going to pull that out for the numerator and the denominator. So write this formula down here for the summation. And once you're ready, let's take a look at example 6. So right away, I'm going to write down the formula. S of n equals a1, 1 minus r to the n over 1 minus r. On this one, okay. And so here, S sub 12 terms. First term, let's plug in a 1 right here. So this is 4 times 0.3 to the 1 minus 1, which is 0. Anything to the 0 power is 1. 4 times 1 is 4. So our first term is 4. 1 minus r is 0.3. 0.3 to the 12th over 1 minus 0.3. And let's plug it into the calculator and see what we get. We've got, I'm going to do the times 4 at the end. 1 minus 0.3 to the 12th divided by 1 minus 0.3 or 0.7. And then times 4. And we get 5.714 as our answer. All right, so it seems like it might be a little bit bigger, but remember the next term is going to be 1/3, not 1/3, 3/10, 0.3 of 4. So it's going to get smaller pretty quickly here. See if you can do the exact same steps on 71. All right, now, if our ratio is smaller than 1, so if our numbers are getting smaller, like they were on our last problem, times 0.3, so every single consecutive term is going to be smaller than the one before it, eventually, we're going to be adding by numbers so tiny that it's really not going to change our answer at all. If that's the case, we can figure out what the sum is of an infinite series. All right? So, but that's only if r is less than 1. R's got to be smaller than 1. If it is, here's the formula. It's very straightforward. The first term, a1 over 1 minus r. If your ratio is bigger than 1, you don't have a sum because it's going to get bigger and bigger forever. It's going to go to infinity. All right, so let's find our sum here for a. A1 over 1 minus r equals the first term, 4 times 0.6 to the 0, because n is 0 here. So that's 1 times 4. Our first term is 4 over 1 minus 0.6, which is 4 over 0.4, which is 4 divided by 4 is 1. 4 divided by 0.4 is 10. All right? So we're never actually going to get to 10, but we're going to get so close that we're going to call it 10. All right, for b, we know the first term is 3, but what's our ratio? 1 minus, well, we can always find that, 0.3 over 3, or we could say 0.03 over 0.3. Two consecutive terms, divide them. So that's going to be 0.1, so 3 over 0.9, and 3 over 9 is a third, and so this is going to be 3.333 repeating. I believe that's right. Let me check that. 3 over 0.9. Yep, 3.3333333. All right, you're up on 93. All right, let's bring it home with a word problem here. We deposit $50 on the first day of every month in an account that pays 6% interest. What is the balance at the end of 2 years? All right, this type of savings plan is called an increasing annuity. All right, hold on one second. Okay, so let's take a look at this. So the first deposit that you're going to make, $50 times 1 plus our interest rate on this one, which is 6%, so 1.06. And then it's compounded monthly, so this one's going to gain 24 months worth of interest. Right? We're going to times it by 1.06 24 times. The next one, we're going to put $50 into the bank, right? And we're going to get 1.06. But this time we're only going to get 23 months of interest on the second payment because it's going in the second month there. The third payment, you put in $50, it's getting 6% interest for 22 months. And then so on and so forth, all the way down until the very last one would only get, our 24th deposit would only get 1 month of interest. So you should see here, this is a summation problem we can do. Summation of I equals 1 to 24 of 50 times 1.06 to the I, right? This is the number that changes, and we're going to get those answers and then add them all up. All right, so let's figure out how much money we've made at the very end. So this is a finite series, one that stops because we end at 24. So our formula for that, S sub 24 equals A1, 1 minus R to the n over 1 minus R. So A1 here, if we plug in $50, 50 times 1.06. Where's my calculator? There we are. 50 times 1.06 is 53. 1 minus, what's our ratio here? 1.06 to the 24th all over 1 minus 1.06. And so let's plug it in and see how much money we would have made here. So 1 minus 1.06 to the 24th. That's negative, but the denominator is also going to be negative, divided by negative 0.06. And we made another $50 times 53. And so $50 a month with 6% interest, we end up with $26.93, $2,693. A pretty nice chunk of change there for 2 years. All right, so your job, see if you can think through 121. All right, there we go. That's it for all of this chapter. And so any questions, make sure we get them answered in class. Good luck.